So I would like to say something more about me, what I have been doing in the last decade. So I passed out from Oriental College of Engineering in the year 2007 from electronics communication stream, and then since last close to 14 years, I'm serving the industry mostly in embedded systems field, and mostly I deal with the deep embedded system and extreme systems. So I'll explain what are all these terms means and how they are different going forward in the session. So my expertise lies in architecting firmware, modeling firmware, and um, system thinking, and debugging the field issues in the system, mostly wireless communication system. So I have worked closely on short-range wireless communication system as well as a long-range wireless communication system. Currently, my role in the organization is to lead a team uh, which predominantly deals in device driver uh, for handsets, cellular phones. Okay, yeah. So pretty much this from my side on me, and yeah. So cellular phones in 2020 is no longer a luxury. Now it is an essential component of our life. So when I say this, what does it mean? Earlier, a high-end phone used to be a gadget in the hands of rich people, but now everyone can afford it. Why? Why people are switching from a low-end phone to a high-end phone? Because the kind of application it has is basically impacting our day-to-day life. We need to communicate. For every reason, we need to communicate for our being everywhere, anywhere. uh, and then the kind of information that we need to lead our life today is very much essential. This information flood has to take a channel, and the channel enablement is being done by cellular phones. So uh, the cellular phones basically enables individual to connect to the rest of the world, which is very remote, which is not seen with naked eyes, but still the information is reaching to us from multiple spheres. So in totality, I would say cellular phone in this century is a revolution. Like Google is a revolution, cloud computing is a revolution, e-commerce is a revolution, cellular phone is a revolution. So when I was a student, e-commerce was just a topic to be presented in papers, but now we are experiencing it. We are experiencing the dynamics and benefits of it all around. You see Amazon, you see Big Basket, you see any other e-commerce platform such as Myntra. You see how much e-commerce has invaded our life. Now, imagining life without all these platforms is a nightmare, especially in the time when we have a pandemic around. So this is what a revolutionary technology, this is how a revolutionary technology impacts our life. So cellular phone is definitely a boon in all walks of life. You talk about healthcare, there are applications which is helping you to tune your health, body, mind. If you talk about any other segment, business segment, the businesses are being run on mobile. It is giving you a 24/7 connectivity to the rest of the world, to different geographies. For example, you are in India, where you have a different time zone and different day timings as compared to USA, which is in the different sphere. The seasons are different, the weather is different, but still, irrespective of all that, mobile is enabling you to connect with that other sphere of the world. So cellular phone was primarily incepted and designed for human-to-human communication. But now it is more than a personal digital assistant. It's a music player, it's a video streamer, it's a musical instrument tuner. So we can just imagine what all services a small device in our hand is catering to. Mobile device is an extreme system. So the kind of engineering happening in this mobile device or cellular phone is tremendous. When I say it is an extreme system, I mean that it has an inbuilt attribute of being available to the user. It is reliable and it is scalable. So what do I mean by availability? So availability is the device is robust and it is always available for user service provided the battery is not completely drained. So of course, like a human needs energy, mobile devices also needs energy. It runs on energy. The battery provides the energy. So if the power system is strong, it is always providing you service, and it has a self-recovery mechanism. So for example, like human errs, devices can also err, but it's about the fast recovery within the system. So if your cell phone can recover fast and still provide you the service, like launching an application, connecting to the web, or sending a WhatsApp message, if it is doing that with low latency within a short span of time, then it is available to you always. Reliability. So this is a very important aspect of an extreme system. So let's say nowadays you are doing banking over your phone, and banking transaction is extremely secure transactions, and you are able to do it without any loss, without any monetary loss. So that means that there is a lot of engineering done so that the device is reliable. So other than life critical system, if you see, mobile phone has almost gained a similar status in terms of criticality because it deals with the money, and a money loss is a huge loss. So coming back to scalability, so now there is a need to run multiple applications, and we keep on switching from one application to the other application. So that means there is something going on in the cell phone to cater to this kind of requirement, wherein you can switch from one application to the other. And those applications are also belonging to different category. They have altogether different taxonomy. So is their requirement on the system. So that's how cellular phone is evolving nowadays. So earlier in the low-end chipset, when it was in a rudimentary state, the components within it was much simpler, but now it is becoming very complex. For example, the processor is no longer a single processor. It has multi-processor, okay? Earlier, it used to be multi-processor system, but more or less very simplified, in a very simplified forms. But now the multiprocessor itself has multi-core, multiple processing execution units are there in the multiprocessor. Then the operating system which used to run on that was not so complex. Now the operating system which is running on these processors are much more complex because the kind of services they are providing, like the power management, um, the clock management. So these have evolved with the evolution in the system on chip. So what are the building blocks of the cellular phone? So this is the agenda. So let's shed some light here and take a deep dive here. So majorly, there are three components in the cellular phone, the magical device in your hand. One is hardware, another is software, and the third one, which is firmware, the least talked about segment in the phone, which is firmware. And it is very essential and critical component sitting in your cell phone. So hardware of the cellular phone consists of many different types of processor, memory devices, sensors, and actuators connected together. Now let me shed some light on the processor which is there sitting in your cellular phone. Mostly and predominantly, ARM systems are housed in almost uh, all the phones in all the segment, low end, mid end, and high end phones. Everywhere there is ARM processor sitting, and the applications are running on ARM. The communication protocol runs on ARM. So when I say communication protocol, it is all your protocol stack like 2G, 3G, 4G, even 5G, and then comes your Wi-Fi, Bluetooth. Your SIM has an ARM processor. Uh, Even your SD micro card, the external memory hard drive that you fit in your mobile phone, that also can have an ARM processor. Okay, so ARM is widespread. Even your graphics, the LCD screen is driven by a graphical processor unit, and which is coming from ARM, maybe a Mali processor. So going forward, we will see more ARM processors sitting in your cellular phone. For example, with the boom in machine learning and the predictive features that are coming into phone, we will see a network on, a neural network on chip processor sitting in our cellular phone. So this can also come from ARM. So ARM has a widespread presence in our cellular phone. Coming back to the memory. Memory today that we are dealing with is mainly in we have RAM, NOR flash, and NAND flash, then NVMe, uh, which is like a hard disk sitting in our phone. So these are predominantly the major memory components sitting in cellular phones. And so now the RAM which we are using in phones is like DDR4. Earlier it used to be SD-RAMs. So there is evolution on the memory side also. Uh, Memory is playing a very critical role in cellular phone because the time which it takes to respond is being decreased. The latency of memory is being decreased so that the device becomes much more faster. The memory access latency is being continuously enhanced. So actuators, to give more and more human touch feel uh, and connectivity to human, basically, I would say, uh, mobile phone is embedding multiple actuators, which is like a mechanical devices. For example, haptic drivers, which is responsible for vibrating the phone. Uh, and then multiple sensors, your touch sensor, your LCD touch screens. So there are multiple sensors. Even there is multiple temperature controllers, which is sitting in your phone. Uh, on the application side, application system on chip side, on the mobile system on chip, modem chips system on chip side, on Wi-Fi system on chip side, on Bluetooth system on chip side, everywhere there is a temperature controller. Why do we need temperature controller or temperature sensor? So this is needed because all these system on chip are running on a very high frequency. And as we know, and as we have read in our academics, in VLSI that a clocking circuitry dissipates a lot of energy because of the current it consumes, and because of leakage current, and because of the switching behavior. Uh, so there is a lot of current flowing through all these components, and the switching actually dissipates a lot of energy, and the system on chips becomes hot. So we need some mechanism to handle the temperature in the device, and because of this energy dissipation there is a rise in temperature. And as we know from our academics that uh, all these VLSI system fabricated using CMOS technology has some breakdown feature, junction breakdown features. So because of the building up temperature, the devices can break down, the components can break down. uh, to avoid all that, there are um, temperature controllers and temperature sensors sitting in our handset in all various component level. So if you take a thermal image of that, you can see hot spot getting developed in the cellular phone because of different components radiating different energy. Uh, and then there is intelligent mechanism around that, to uh, control the temperature. One more point I want to add here, connecting back to your academics and the stuff that we read in our uh, colleges, that this cellular phone has multiple RF systems. So there is a RF system for uh, Wi-Fi, RF system for Bluetooth, wireless RF system for NFC, near field communication, and then your cellular, of course, 4G, 3G, 5G. So all these RF system, uh, they consume a lot of energy and they dissipate a lot of energy. Okay, so uh, we need to have certain sensors. As I said, like we should have a temperature sensor. So this is a very, very essential component. And why I am stressing on this, because uh, this is the time when people in academics, they can do research on this. They can study more in depth about the temperature management. And going forward, as we see the Moore's law, that the devices are becoming complex day by day, there will be more requirement to efficiently manage energy dissipation and temperature control in such devices. So that's why I am stressing on this topic. Another important component is software. So this component is majorly the general purpose operating system, which is sitting there uh, housed in our cellular phone, and which provides the services for the application that we use. So talking about an Android phone, uh, we can take Linux as an example for this. Android phones has Linux as an operating system kernel sitting on the application processor. And application processor is responsible to execute your applications. So Android, if you talk about Android, it's a wrapper software component or framework, uh, which is based on Linux kernel. And there are some middlewares. So what are these middlewares? Middlewares are actually a set of libraries which provides services to the applications which is sitting on top of your Android. Why do we need middleware? So middleware is needed for better portability of application. So once you have, let's say you have developed certain application for Android phone and you want to port it on an iOS phone, um, if the underlying component that you use, the external components that you use, the libraries that you use to talk to the uh, hardware is uniform, then your effort goes down and you can seamlessly port your application from an Android phone to an iOS phone. So this is the reason we have middleware. Then another important role of middleware is to connect two different world of programming languages. So taking an example of Android system, uh, you have certain components in software written in C or C++ and certain components written in Java. Now, you want to make these components talk to each other. How do we do that? For that, we have a Java native interface library, which connects the C++ world to the Java world, and the two components, the libraries or an application, can talk to each other through JNI. Now, JNI in Android phone sits as a middleware. So another middleware example could be Java virtual machine, which is sitting in Android phones to run Java applications. So these are the software components, and they are sitting on top of the firmware components. So the firmware components are majorly the real-time operating system, the device drivers, the protocol stacks, and bootloaders. So in my view, these are the four major pillars in our cellular phones under the category of firmware. So when we say firmware, what does it mean? In my definition, firmware is a piece of code which is not frequently changed. Though it is changeable, we change it, but it is not. The frequency of change is not as high as the frequency of change we see in a software. Change in software is relatively done faster, and it can be done faster because of the ease with which we can manipulate the software, because of the support we have from the whole ecosystem of software development. But firmware is an engineering field, and it is a bit complex. There are multiple players in firmware, because of which it becomes a little bit intricate, and it is not so easy to go and change firmware now and then. So what is a real-time operating system? How is it different from a general purpose operating system? So a real-time operating system, in addition to managing resources, when I say resources, it means the hardware component, the CPU, uh, the peripherals, um, and memory. So all these resources, in addition to managing resources efficiently, RTOS also ensures that it will abide to the temporal constraints. So when I say temporal constraints, that means meeting the timelines. And timeline is an important requirement for real-time systems. So let's say uh, we are streaming a video on our phone, and the video frames takes too long, and it crosses the human perception of continuity. Then you will start seeing jitter and pause in the video. At the end of the day, user will not be satisfied with the video streaming. So the video streaming should be done uh, within proper time intervals. So the frame rate should be within the human perception of continuity. If it is not, then the video will appear very jittery and very intermittent. So user will not be satisfied, and he will and then we will say that the device or the cellular phone is not available. So that is how a real-time operating system is different from a general purpose operating system. Another difference is real-time operating system does a very specific job. Okay, but a general purpose operating system caters to multiple services for different application like video player, but real-time operating system is not designed that way. The machinery is altogether different. So where does it sits? You take any component uh, down the general purpose processor, and it has RTOS. You talk about Wi-Fi chipset, you talk about Bluetooth chipset, you talk about NFC chipset, you talk about your SIM card, you talk about your SD card. All those has RTOS sitting there, one or the other kind, fine-tuned for a particular requirement set. Okay, so some components in our system needs to be high performance. They need to run on a very high clock speed. Some components need to be a low power component. They need to consume less power. All these RTOS are hand fine tuned for those purposes. Okay. Now coming to drivers, I would request to please mute. There is a background noise. So coming back to drivers, drivers majorly are frameworks provided for efficient input and output. So when I say input and output, what does it mean? It means the IP packets. It may mean some internal messaging between processors. It may mean uh, communication between the two different cores sitting in the same processor. So there are multiple drivers, drivers for memory, driver for peripheral, uh, and driver for sensors, drivers for actuators. So these all are part of drivers. Now, protocol stacks. There are multiple protocol stacks sitting in our cellular phone. There is a protocol stack for TCP/IP. There is protocol stack for 3G. There is protocol stack for 2G, 4G, 5G, then NFC. Even your SIM card has a protocol like T is equals to 0, T is equals to 1. More or less, these protocols are layered architecture, and they follow OSI model, more or less. Some of the layers are basically uh, ripped off. So it's not mandatory that we strictly follow OSI model. So, but whatever we study in our academics are there in our hand in the cell phone. So, and now we can understand the importance of the protocol stacks and the stuff that we read there in university. So there can be multiple TCP/IP stacks sitting in your phones. Some TCP/IP stack instance will be there in your modem. Some can be there in application processor. This is to short circuit the communication and reduce the latency in communication, which is going to be a major requirement for 5G. So now another essential component in firmware segment is bootloaders. So you need a special piece of code or framework to start bringing up your phone or to initialize your phone to a usable state. So bootloader is predominantly a component which does this job. It initializes your phone, and nowadays it's not so native, and it has evolved, and it caters to some new kind of requirement. For example, bootloaders nowadays provides you services like firmware over the air update. So it is also called OTA or FOTA. So wherein, let's say your phone has a bug, and it is being detected by the phone vendors, the phone manufacturers, and offline, and the solution is pushed to your phone in form of upgrade uh, and over the air using the protocol stack like 4G, 2G, or 3G. And then the bootloader sitting on your phone actually applies the upgrade, and then your phone recovers from those kind of bugs. So you can imagine how all these components are maintaining the continuity in service that it provides to you. How what kind of engineering goes in here in the cellular phone to help you get connected with the rest of the world. and provide you 24/7 services. But if you think deeply, all the root lies in your academics. We have not gone very far away. Every now and then we need to get back to the basics. Though engineering will be complex going forward because of increasingly intricate requirements, complex requirements coming our way, but still the root will lies in the basics. The root will lies in our academics. The root will lies in what we study there. So let me move on to the next topic. So having said all this, what we should do? So we should just participate in the ongoing revolution. I feel it's our good luck that we are here in this era, and we are part of this revolutionary movement that is happening in technology. So in order to participate, we should read a lot, do research in the areas uh, in our academic, uh, whatever, kindle your thinking, stick to it, do some research, read thoroughly, develop a tendency to deep dive, and then practice. Practice what? So practice some skill set that you have decided. It can be coding, it can be designing, it can be design modeling, and then try to implement something, make something tangible, make something realizable. Okay. And then once your implementation is done, validate it. Is it up to your expectation? Is it up to a user's expectation? How the world feels about it? And then try to sell your idea into a product, convert your idea into a product, and keep on doing this right from the very beginning. If you are accustomed to such kind of cycle, it will give you a lot of leverage, a lot of confidence in corporate world. And actually, you will be in the group of innovators, I would say. So, so this is the time wherein you can do all this. You have immense time to do all this in your academics and in your student life. But once you get into a corporate life, there are various factors which will drive you. Something will be under your control, something will not be under your control, and you will have less time window to do all this. But if you start practicing all this now, you will be so accustomed to this that you will be able to steal time and do your own research later in your corporate world. So why we should be continuous and why we should tirelessly keep on doing the same thing? It is because of the complete nature is evolutionary, and anything that we take today starts from a rudimentary phase and then it gradually evolves. So if you see the current slide, we evolve from a rudimentary system to evolved system by increasingly adding delta into the system cycle after the cycle. And a cellular phone is the right analogy for that. Earlier, back in a couple of years, it was a very basic model. But the OEMs, the mobile manufacturers kept on evolving it by adding new features to it. So nothing was done in one day. Rome was not built in a day, and it was all gradual. And still, there is no upside down changes. Okay, so people in the industry has taken very small steps to come to this stage wherein we are today. Okay, and still the underlying things are same, underpinnings are same. So the firmware also is not drastically changed. So based on my experience and seeing certain systems very deeply for as long as a decade, I have seen that even the firmware components are still the same. So it is building gradually, brick by brick. So spend some time in understanding that and try to evolve yourself. Consider yourself as a system. Add certain skills and knowledge into your knowledge basket, into your capability basket, and see that you are also evolving like other systems. Now, I'll tell you a short story. When I joined the industry back in 2007, so it was a software company, and my mentor told that if you want to excel in software companies, um, you should learn three things, and you will be master, and you will excel in this software industry. And those three skills were a software programming language, a database system, and then an operating system, preferably Unix. But I would say in this era, in this century, the dynamics has changed a lot. And now, so is the need for the skill set addition. I feel that the sixth component that I am mentioning here is the Brahmastra for future readiness. So one is a programming language, preferably C++, because it has the elements from both the world, the procedural world, as well as the object-oriented world. So it is a close cousin for C as well as Java. And nowadays, because of multiple instances of anything, be it processor, be it a peripheral, like for example, you have two SIM slot in your phone. So that is a multiple instance of a single entity. So it all can be treated as an object. So we need an object orientation thinking in our development approach. So this is why I insist on learning C++. There are certain components which is completely developed in C, but people who know C++ can move from procedural world to object-oriented world. So this is a good starting point. And I feel that this is the most complex language, programming language. So once you deal with the complexity, the easy things will just come to you. Another thing is a scripting language. Python, I feel, is a very good language. I'm not advocating or selling all these components, but because of my experience in these areas, I'm suggesting these things. So Python has a lot of support. It has data analytics support. There are packages, there are libraries which can help you do data analytics. It can help you run complex algorithm. Um, and you need not to develop it from scratch. No reinvention of the wheel, and it supports your graphical user interface. So currently, we need to do a lot of number crunching in industry, and we need to present our data in more interpretable form and usable form. For all that, Python plays a key role there. You need to learn a processor. So processor, I prefer that people should learn ARM processor. I recommend it strongly because ARM processor is all pervasive, except servers. It has not made much way into the servers for cloud computing, though there are some pilot projects or a few products based on ARM, but still the small devices or the gadgets are mostly based on ARM. Then the next skill set that you should add to your kitty is a real-time operating system or an operating system understanding and knowledge, in-depth knowledge, I would say. A Linux and FreeRTOS the GNU licensed RTOS are good enough to get started, because there are a lot of support around this that you get from multiple forums. And there are a lot of tool chains which is freely available. So during your student age, in this time, you can freely access all these materials. You can get very good support um, all across the globe, from all across the globe, and then you can get started easily on these things. And more or less, all the RTOS are same. So uh, a famous RTOS author has mentioned in his book that if you learn the generic concept of real-time operating system, it is applicable everywhere. You talk about VxWorks RTOS, MuCOS2 RTOS, Free RTOS, for that matter, ECOS, anything you take, any RTOS you take, Nucleus Plus RTOS, they are all, they all have similar components. Um, so ThreadX is another popular RTOS, which is being used in the industry. ThreadX and Nucleus Plus VxWorks, these three has widespread usage. I would say we should also understand and know deeply about one protocol stack. TCP/IP maybe is a good um, thing to learn, and we should master all the layers, all the nitty-gritty for all the layers in TCP/IP, file layer, MAC layer, network layer, for that matter, transport layer. Every layer we should understand thoroughly. This will give you a very good mileage in corporate, because the kind of system which we are going to see will have all these as underpinnings. Now, what do we need more than this, other than that, other than the technical skills? We need to have abstract thinking. So when we say abstract thinking, what do we mean? So for any entity which comes our way, we should shed some thought to it. We should try to understand and think over it in multiple perspective. Why this entity exists, and then what is the usability? Okay, let's, and then we should develop a 10,000 feet high view on that object or entity in our hand. So if you talk about cellular phone, one way of looking into it is seeing through and looking at the component which is sitting inside, which makes the cellular phone. Another way of just looking at it is as a device which is used for communication. Okay. Uh, So this is an abstract thinking. When I say it is just a device, a black box, which helps us connect to something, connect to a device, or connect to another human. So this is a way of thinking at a very high level without thinking into the nitty-gritty of the system. So we need to develop abstract thinking. Until and unless we develop abstract thinking, it's very difficult uh, to create something, innovate something, develop something, some product which is useful for the user. Another critical part of it is mathematical modeling. So when you say you have developed abstract thinking, you should be able to represent it in mathematical language. For example, I'm just giving an example. Let's say your phone components, I treat them all as some object, and I want to create a set of components, because some of the components will be alike and some will be different. So we can group together the similar components, okay, and create set of components. Now you see, when you have set, you can apply set theory to it, right? You can apply all that procedure which we have learned in the set theory. Now, if you see your cellular phone, it goes through multiple states. It boots up, it is in aeroplane mode, it is turned off, then it goes to a power saving mode. Uh, so all these states, if you see, it forms a state machine. Now, uh, all these state machine can be treated mathematically. So in the industry, there is a big void, a big gap. wherein people, at least in India, are not doing this to a much larger extent. So modeling a system which can be interpreted by other users or other developers or other engineers is not being done to a greater extent. So I would urge the students here to develop the skill set on modeling a system, on representing a system on paper, on documents, mathematically as well as graphically. Uh, this will pave the way for other engineers, to uh, create something amazing. Um, One more point here is, currently the corporate works in an enterprise team structure wherein all the team is distributed across the geography, and we need to communicate technical things with the different teams. Um, when we talk about different geographies, they have own language, native language, and it's very difficult to communicate in English to them because they have their own native language in place. So what brings in as a common language is this modeling, either a graphical modeling or a mathematical modeling, because that sets up a common language between two engineers in different geographical locations speaking different language. So I urge students to develop competency in this area. Another part which is more human skill is system thinking. So when I say system, it's about understanding the components, their interconnection, their usability, and all the attributes that a system has, their balancing factor, their imbalancing, all the components which is there in the system. So, and their attributes. So system thinking is very much essential. And now, this is something which we need to develop, and this is the right time to do it. So another skill set, forestry viewing. This comes from system thinking, I would say. This is just a sub part of system thinking, wherein given an item or entity, for example, cellular phone, you can get into the most abstract view, uh, and or you can go into each component and tell the details what is happening there. So a tree view is just like moving component to component and understanding all the nitty-gritty of the components. And a forest view is perceiving the entity or viewing the entity from 10,000 feet height and understanding the usability of it. Now, what is the world going to see after COVID-19? So COVID-19 has given a big jolt to the industry and to the human living. And now everybody has realized that there are some certain things which is, though predicted, has been neglected, like a pandemic, which was predicted almost a couple of decades ago. And even in 2015, Bill Gates had predicted this. So prediction being ignored is one of the risk which we are dealing with now. The repercussions are there with us. So what is going to happen now? Now that we realize that there are multiple gaps and void across the systems, we would like to fulfill it in coming years. So after recovering from COVID-19 crisis, the industry will look to bridge the gaps and bring in automated system which cannot be affected by viruses, for that matter. So what can be those things? Those things will be machineries. And before COVID-19, there was a launch of Industry 4.0, which is like, I will explain more about Industry 4.0 going forward. So Industry 4.0 is a new revolution which the technical world is seeing, and it is just the stepping stone, and it is in a nascent phase. We will see more about it. And To work in Industry 4.0 and enjoy 4.0 services, our engineers will have to stick to the basics, build up their competency, and understand the demand it will create in the engineering fraternity. Uh, so post COVID-19, there is going to be a huge surge in Industry 4.0 requirement. It may be re-specified in many terms, and there will be acceleration and in the pace that with which Industry 4.0 drive is moving. So engineers, I would urge you guys to know more about this Industry 4.0 revolution. And there is going to be huge demand on quality engineers, quality leaders in this area, in the technical world. So talking about industry journey from Industry 1.0 to 4.0, Industry 1.0 was somewhere around 1700 century and 1800 century, wherein people started using animals and rudimentary tools made up of wood for efficiently working on their artifacts. Um, and then moving to Industry 2.0, somewhere early 1900, the industry started seeing small machineries, which was not electronic, made up of steel and heavy electrical equipments. Then came Industry 3.0, somewhere around 1950, which is mostly based on large computer systems and electronics gadgets. But now Industry 4.0. So everywhere till Industry 3.0, in humans needed machinery for assistance, and there was only human to machinery communication uh, through cyber physical systems. But now in Industry 4.0, machines will interact with each other, and uh, to do that communication, we will need wireless channel, we will need wireless communication system, we will need wired communication system, and we will need multiple sensors, we will need wireless sensor network, we will need, again, all the building blocks, which I explained you earlier. And now we know that the importance of predictions. So in Industry 4.0, to avoid multiple type of risk, there will be multiple predictions being done on multiple level in almost all the system. And to do that predictions, there will be machine learning systems, be it hardware, uh, in assistance with firmware or software. So all those things is going to take place in Industry 4.0, and this will need a lot of capable engineers and leaders in the industry to drive Industry 4.0. So currently also we see a machine-to-machine communication using Bluetooth channel or Wi-Fi channel, but there will be more such wireless channels like Zigbee, uh, Bluetooth LE, low energy, to communicate between two machines. So, and this will all need a high data rate because once the machine will start communicating, the rate at which they will generate data will be huge. And to cater to this, our system should be capable to handle high data rate. Um, then since we will have multiple transceivers in our environment once the Industry 4.0 is fully set up. uh, all these transceivers will deal with multiple input output antenna system, um, and 5G is going to be a key role player, uh, a game changer for Industry 4.0. It is being fine-tuned for all this requirement uh, to cater to high data rate and high density of communicating devices in an area, and then to mobility, of course, because the seamless service we will need while we are moving from one place to the other place, or the devices itself are moving from one place to the other place. So all those things keeping in mind is setting up the stage for Industry 4.0. And so I would urge you all guys here who all are listening to me to be prepared for Industry 4.0. In this time, in this crisis situation, do just two things: protect yourself and prepare for the better future. Okay, I would open the mic for question and answer session. One by one, people can take turn and ask me questions.
Participants, any questions from your end? Yes,
Anch,
Anchal.
Hello.
Good
yeah,
morning,
Anchal.
Anchal.
Hello. Good morning, sir.
Good morning.
Hello. Sir, I have one question. Sir, what do you think that convolutional neural network is good for mobile application? Sir, I know that it will increase the accuracy, sir, but what about computational complexity and resource utilization?
So there is research happening in all areas, and the devices are moving from uh, somewhere around 20 nanometer to 10 nanometer and then to 4 nanometer. So fabrication of chipset is decreasing day by day, um, and such complex algorithm, not fully but partially, it is getting implemented in hardware itself. So certain component of CNN can be handled on the firmware or the software side, and certain components can be handled on the hardware side. So as of now, industry has both the components for neural network. But going forward, I don't think any impediment for having a complete hardware solution for neural network implementation, or with a very thin layer of software intervention. So there will be possibility, because research is happening all across. And one thing I would like to highlight here is we have to understand that the material science, which is uh, the baseline for our VLSI or semiconductor industry, is also doing a lot of research so that efficient semiconductor materials and components and devices can be produced. So yeah, uh, did I answer your question, Achal?
Yes, sir. It is satisfactory on other classification like KNN and decision tree. So, but I have one more question, sir. It will recognize our activities, sir. It will help in like in the better accuracy, sir. But it has more complexity. So, sir, how can we program this like things like in future? How we will implement? I have
So
this question.
yeah, I understand your point. So basically, uh, neural network as of now is basically assisting people, assisting users. They are not sure shot solution for anything. There in this world, there are certain problems that we solve, but we don't have a exact solution for that. It all works on approximation. So even if we are close to the solution, it is good enough, it is acceptable. All these falls under approximation algorithm. A prediction is not 100% sure all the time, but it is probabilistic. So even in human life, we take decision based on probabilities. Uh, and even the risk and severity of the things are also measured in terms of probabilities. So we are good to accept some approximate solution for our problems. Machine learning, for that matter, falls under the same category, wherein it solves our problem to an extent, but not fully, I would say. Yeah.
So, sir, how much year it will take to implement all these things in your views?
I think uh, machine learning is all pervading. It is being used in cloud computing, in e-commerce. You take any platform, they're all using machine learning for learning. If you see, I can give you a live example. When you go to Amazon site to buy something and you see that there are certain recommendation coming for you based on your previous searches or based on your previous purchase record, it is machine learning. They are at the back end, they are doing some prediction that when you are coming on the Amazon portal now, what you are going to buy.
Yes, sir.
So it
So,
is all
thank you.
there. It is all there. It will just evolve. It will just evolve, and it will become it will come closer to provide you 100% solution.
Thank you,
Yes,
Anchal.
thank you.
So,
Falguni, I think
Hello.
sir,
there's
I
one
got a
hand.
question for you.
Yeah, Mr. Shankar, go on.
How do we take care of this jitter in mobile phones,
Okay, so
in
uh,
video streaming especially?
I'm not a video expert, sir, but I would
Okay.
say like there are components sitting there. One is like even the clock source, which we have, right? Based on its cost, some expensive clock sources has very low jitters. Okay, like the phase lock loops that we have.
But eradication is not possible, isn't it?
Eradication 100% is not guaranteed because of multiple reasons. Because of uh, the system on chip compact packing of multiple
Okay.
components, there are chances of EMIs, electromagnetic interference, crosstalk, which can lead even the temperature for that matter. Temperature brings in a lot of instability in the clock sources, so there is jitter. Sometimes there is jitter even if you have expensive and very reliable clock sources.
Thank you.
Yeah, next question, Falguni, you can go on.
Sir, I have a question to ask. As we are moving towards Industry 4.0, can we expect that machine learning models will be integrated with security solutions, maybe minimizing the amount of security attacks?
Definitely it is going to happen, and security will go hand in hand with the uh, predictive solutions based on machine learning. Security is going to be a key role player in 4.0.
Thank you, sir.
Hello, sir. Good morning, sir.
Good morning.
So, sir, I want to ask that as we are talking about components of phone, mobile phone, so I want to ask about battery. Recently, I have seen that Samsung is going to use a graphene battery and it will likely to come in 2021. So, why it is challenging to go with a graphene battery, although it has a many advantages?
Graphene battery. See, I would say there is for every battery, there is some characteristics that we look for. Okay, so now the most sought feature in battery is fast charging. Okay, and very slow discharging. For any user, this is the basic feature which we will take interest into. So if a graphene battery provides this attribute, of course, that will take a priority to get into the cellular phone system.
Okay, thank you, sir.
Vaibhav is raising a hand. Vaibhav, your question?
Uh, Good morning, sir. Can you hear me?
Yeah, I can hear you.
Yes, we can hear you.
Okay, sir. As we are moving towards the introduction of 5G and Industry 4.0, my question is, will there be any effect on the on-field jobs? Because the whole point of 5G is to reduce latency, and a major chunk of development in 5G is based on the uh, uh, broadening the applications of Internet of Things. So if because there was previously there was a problem of latency, that is why the IoT for industrial applications was kind of limited. So by the introduction of 5G, we can potentially make some systems which can be used to control a mid to large scale industry from home. So will there be any job cuts for field engineers or something like that? I want
I
your
don't
views.
think I don't think there will be job cuts. Rather, I feel there will be more demand on the job side, but the demand will be different. Demand will be for highly capable engineers who can deal with the complex systems. Okay, so
Okay.
uh, the whole uh, software or hardware world is changing. Okay, so now in 2020 century, we have to acquire different skill sets, so the demand is going to be different. That's what I can say as of now. Okay, it's not going to be the same, but there will not be job cuts. There will be more jobs.
Okay, sir. Okay, thanks.
Hello, sir.
Hi,
Yeah.
Good morning, sir.
Ankit?
It's
Yeah,
good morning,
Ankit, you're
sir.
audible.
good
Yeah, good
morning.
morning.
So my question is, sir, as we are moving towards the industry 4.0, where we can see that all the things are going towards the automation process. Because of where we in industry 4.0, we are combining multiple technology like machine learning, AI, security purpose, DevOps, all the things on a single matter. So, according to the electronics engineer, how can we see that? How can we know that we are doing the industry 4.0 according to the in industry use cases, so that we are or we are living in the Corona decade, where we are have to minimize the social distancing like things, and we are doing the all the things according to monitor social distancing, so that how can we see that sir, we are monitoring the social distancing, and we also implement the work in the industries according to the industry 4.0.
So basically, Ankit, Ankit or Vaibhav?
Yeah,
Ankit.
Ankit.
Okay. So basically, though we are maintaining social distancing, the technology today has came all the way till this point wherein we are connected remotely over the web, and nothing holds us back in forming a team and doing things collaboratively. Okay, even now in this situation, we are working for our corporates, we are working for our offices using the platform which we have through internet. So for engineers, I don't see any barrier. Whatever system we have in our internet, that is sufficient to uh, cater to our current needs. We be it data rate or whatsoever now also you see, I am sitting in Bangalore and I'm connected to you guys, and you are far from me. So nothing is coming in our way to hold us back in collaborating and doing teamwork. Okay, and nothing is stopping us for preparing for industry 4.0, because a lot of information is freely available, uh, and it's just about doing our bit. It's just about putting effort in the right direction with a team, which is very essential now, and then moving in the right direction towards industry 4.0.
Okay. Sir, but we are a electronics engineer. Where when will the industry will open? Then we have to go in industry and work there. So where can we are doing the things according to the industry 4.0?
Yes, I would say now also whatever is there in the academics, we are totally aligned with the industry. The underpinnings, the underlying things, the basics are same, and they all are being used on a daily basis in our industry. So your studies are not going in vain. Whatever you guys are doing is very much essential for your journey in industry. So I would say, I mean, just stick to your academics, do well, get a deep insight in your subject knowledge. That would suffice, and will make you a good industrialist or a part of industry as well.
Okay, sir. Thank you so much, sir.
The hand is being raised by Mr. Akshay. Akshay, you can go on. Akshay Raikwal, is it there? Nikhil has raised a hand. Nikhil, you can go on.
Hello, sir.
Yeah,
Hi,
hi,
Can
Nikhil.
you
Nikhil.
hear? Yeah, sir. Coming from learning point of view, like you mentioned those technical skills that one possess. So the other things like programming languages are fine, but how one can go from x86 architecture that is being taught in college to ARM, like ARM architecture, and how one can learn ARM processor,
Yeah,
because the resources are very scarce as of now.
yeah, I understand your question. So basically, ARM earlier it used to give a lot of free materials, and the learning system in ARM was very good. So that's how even I picked up ARM
Mhm.
10 years back, and but even now, I feel that it's very easy to pick up because of the forums that we have. Okay, so I have a small board to show you here. This is a Tiva C series board based on ARM Cortex M4. And this is for academics purpose mostly. This comes from Texas Instruments, and Texas Instruments gives all the software free for this board. Okay, so this can be a good starting point. Get a small low-end Cortex M3 ARM processor board and start doing stuff, software or firmware development for this kind of academic boards. Okay, and then whatever board you buy, either from Texas Instrument or from let's say ST Microelectronics, they have sufficient materials to provide to you, tool chain freely available from all of them to help you enable on this such kind of platforms to work. Okay, so you will learn the tool chain, you will learn the compiler, you will learn whole of the environment. Then when you will write the software or firmware for this kind of platforms, you will understand the hardware architecture as well. So I would say get a board from such vendors, a low-end board, a low-cost board, and get started.
Okay, sir.
Revti has raised a hand. Revti, you can go ahead with the question. You can unmute yourself and go ahead with the question. Revti, can you hear me? Revti, are you there? I think she has lost connection.
I think there is a problem.
In the meantime, I'll like to ask the question to Mr. Shashank, having the privilege of knowing him in his college days as well. So most of the students who start off on the journey today are aspiring to get into the IT industry, in spite of the fact that they are graduating out of a very core branch. But uh, whenever I see them doing all these things, I happen to give an example of you to them, that you were one of those people who was one of those students who was always, I mean, getting into the technical hang of things, always making projects and developing things. And so you were destined to be someone who's going to enter a core industry. So from your perception, what advice you'll give to all these students that uh, as to how to get into a core industry, yet staying updated with the softwares, because they are a essential thing now, but still being graduating out of a electronics background, how to prepare yourselves for a core industry like what you are into right now?
Yeah, thanks for your kind words, sir.
Most welcome.
Actually, this core competency is one thing that we have to develop into getting into the core areas. And this is a very valid question. I see many people running after the software industry and not towards the semiconductor industry, while even though they are coming from electronics and communication background or electrical background. So electronics and communication and electrical streams are more aligned towards semiconductor industry. And our industry actually looks for a competent engineer, but we hardly get a few people who can understand the intricacies of our system. So answering to your question, Professor, actually there is an overlap between the software industry and the semiconductor industry, which people hardly realize. And this overlap is a boon as well as a bane, I would say. It is helpful, advantageous, and disadvantageous too. So what is happening in current situation is people are coming from software industry and they are finding way to get into semiconductor industry. But semiconductor industry is not a core software industry. We need certain different skill sets. We need people who can understand hardware thoroughly. We need people who can understand logic gates. We need people who can understand sequential circuit. We need people who can understand combinational circuit. We need people who can understand uh, the timing diagram. We need people who can understand uh, computer system organization. So we need people who can understand analog to digital converter, digital to analog converter. So this sets up altogether a different requirement. We need people who can understand voltage, current, power, energy, impact of time, propagation delay, and then also relation of all this to the software system. But people coming from the software industry, getting their way into our semiconductor industry, they have a very local view of one component, and then uh, the kind of support or the kind of uh, activity, tangible output that we seek, it doesn't come from that area or that side. So this is a big gap. I encourage all the students, and I would say, so why you should put so much of effort of knowing all these things, and why you should join semiconductor industry? That is another set of question, because it's very challenging. Human mind works best when it is challenged. So definitely our industry is the most challenging industry, and the kind of complexity that we are seeing, we are moving towards some kind of a rocket science engineering, and then it is highly paid area as well. So uh, the remuneration as compared to software industry is much, so it is worth putting effort in this direction. And I don't see any reason, when people have a background of all such knowledge basket and knowledge base, why do they go for software industry? I don't see. Even from the job perspective, I would say semiconductor industry has more stable job. Uh, they will not ask you. There is no much attrition. There is no much layoff in semiconductor. It is very stable. I would say uh, it actually eases the life of an engineer, because it is more mechanical in terms of the job you will do on daily basis. There will be things which will change in 10 years, but those uh, those the items that you will deal with on daily basis will still have a good set of challenges. Yeah, pretty much this.
Falguni, again, one more, you are raising hand. Any other questions from your hand?
Yes, sir, I have a question. Sir, I think that this year can be called the year of stagnation in the productivity growth because there's not much in the industry. So there are many articles that are stating that revolutionary applications are rewriting the rules again, the rules of digital and analytics and whatnot. So where will the main challenge in the industry will come in terms of this quantum leap?
Yeah, so when you say rewriting the rules, that's true. We are rewriting the rules. Even Industry 4.0 is rewriting the rules. 5G is rewriting the rules. So we are rewriting the rules because that's the need.
Yes, sir.
And talking about the quantum leap, of course, once this crisis situation will be over, there will be a leap. Okay, I think down the line, couple of years more, let this wave settle down, and there will be a quantum leap.
So the what are the main field in which the majority of the quantum leap will be witnessed?
The major areas which will see the quantum leap will be machine-to-machine communication, as I said, and then human-to-machine communication will also see a quantum leap. Okay, another area which will come into picture, I think, will be the financial sector. I'm not an expert in that area, but the financial sector will see definitely some quantum leap. Maybe because of the cryptocurrencies which is coming in way and the security which it needs. So there will be some big changes there too.
Okay, thank you, sir.
Thank you.
Harshit is raising a hand, I guess. No, Harshit, you have a question?
Yes, sir. Sir, I have one question to ask. As I am an electronics engineer, sir, I have so much interest in the hardware side, but I don't able to find any of the job that I have interested in. Like, uh, I used to play with Arduinos, Node MCUs, and all the stuff related to IoT. But when I used to search on internet that what are the jobs related to these things, I don't able to find that. Yes, some companies working with those or anything. So I wanted to ask that if I have a knowledge of hardware as well as the software, what are the opportunities for me?
Before even Shashank starts to answer the question, I'll interrupt in this and say the live example in front of you is Mr. Shashank Vimal. This is exactly how he used to be. Every other time when he used to enter the class, he used to have a set of the screwdrivers and everything, and we just given him an opportunity and he'll try debugging in the devices. So it always pays off. It always pays off. Yeah, Shashank, go ahead with the answer.
Yeah, sure. So actually, as Professor Ahmed rightly said, it will all pay off. Your all hard work will pay off. That's very true. We should have intention and we should act accordingly. Just do the next right thing and your goals will come closer to you. Okay. So there are now two ways for job to get a job. One way is employer comes to you, interviews you and take you. Other way, you come in the lights of employer. You create and showcase your talent. Now it's a global world. There are multiple global platforms wherein you can come up, talk about your skill set, show your competency openly, and show your skill set, and you can impress the employer. So what you can do is you can always find out the right forums, get associated, participate in the right forum, project your skill set, project your personality. Now, I would say a very important uh, insight that I want to share with all of you is like industry is not now looking alone for skill set. Industry also looks for your interpersonal skill and the personal attributes that you carry. More or less now industry is not counting engineers, they are counting on leaders. So leaders are a blend of personal attributes as well as technical abilities. Okay, use this global forums, come up, show your competency. You have a hackathon, you have different platforms. You have now GitHub, wherein you can submit your code, your solution, and share it with the world. Participate in open source systems like Linux, uh, and then share it with the world. Let the world know about you if you are doing all this and you are putting so much effort. So just open up, come on the global platform. You can even write about what all those things you do, blog about it, uh, and then you can participate on LinkedIn forums. So these are the things which can bring you in the eyes of employer, your competency in the eyes of employer. Use the global platform. That's what I would suggest.
Okay, thank you, sir. By the way, sir, I am on those platform already, sir. I'm active all in all those platforms like LinkedIn and GitHub and all other platforms, which is in popular. Thank you, sir.
Thank you.
Any further questions from any of the participants? Dr. Nikita, you had a question?
Yes, sir. Hello, I'm Dr. Nikita. Good morning, sir.
Yeah.
Yeah, actually, I had a similar question because in nowadays the EC students they want to get the jobs in the core companies in the cellular mobile field, but in the colleges or in the placements generally the IT companies come for the placement. If you can help students to know how they can get into the telecom industry or the cellular mobile industry or something to their core industry.
Sorry, Nikita, can you come back again? I missed your question
Okay,
slightly.
sir. So yes, sir. I was saying that my question is similar. Actually, generally, students of EC branch wants to build their career in the core field like cellular mobile field or telecom industry. But in the colleges or in the placements, generally the IT companies come. So can you help them know how can they help into get into the telecom industry or the cellular mobile industry or the core industry of electronics and communication?
Okay, so here I would say like corporates and companies, communication companies or semiconductor companies, they also do a headhunt. They are also looking for competent brains and capable minds. So what they do is they launches multiple challenges, contests online. This is one way they do the headhunt, and then they go to the campuses. And I think now there are some third parties all around from which they have a tie-up to see your scores. For example, hackathon, I believe I think Top Ranker is another, if I remember correctly. So there are certain third parties which launches such contest, and companies have some link to the third parties to get the data from them and see how an individual is performing on their platform. Uh, Even when it comes to recruitment, companies sees a lot of data, they searches a lot of data over the net, over the platforms which I mentioned earlier, and then they try to get the good fit for their requirement. So uh, now for the campus recruitment, it's about college also. I would say that how much uh, college is projecting the work and mostly the research work to the corporate. So this is something which I feel has some gap today, wherein the institutions are not projecting much of their research work to the corporate. So there are certain areas which I believe even uh, industry wants to outsource to institutes to do R&D. R&D could be a major channel through which educational institutions can go hand in hand with corporate. Uh, but at the same time, the most important factor is to building up the competency of our students, maybe, and then joining hand with the industry for the R&D activity. This could be a very good channel to start with.
I'll take the last question from Anuradha Rai because
Hello,
the
sir.
other, yeah, Anuradha Rai
Ankit.
or
Yes,
Rashi
sir.
Sajdev. Anuradha, are you there?
Yes, sir.
Yeah, Anuradha, go ahead with the question.
Good morning, sir. Sir,
Morning.
what are the job opportunities in the field of semiconductors? So, as I have quite interest in the field of semiconductors, so what are the job opportunities and how do we get those jobs in the field of semiconductors?
Okay, so the job opportunities that we have is uh, right from analyst position to designer to validator, uh, and then field engineers. So when I say validator, you understand that we have two segments in semiconductors, both the software part and the hardware part. So the scale of requirement in our industry is bigger than that in uh, any other industry. So we analyst, when I say we need multiple type of analyst, performance analyst, power analyst, these all fields has emerged into a big ocean, and they have a lot of things to do. So that's why we have requirement for a specific analyst for one area. Then we need people who are very good at designing. We need people who are very good at customer engagement. That is pretty much little bit less technical role, but these are the requirements majorly we have
So,
position wise.
and which type of softwares are used in those industries?
So we use multiple softwares. We have a software dedicated for performance analysis. We have software for dedicated for power analysis. We have software for compilation of our code, building it. So we have softwares for measurement. We have softwares for further filtering and what to say, data mining. So we have multiple type of software that we deal with. I can't just name one. There are multiple.
Just one more minute for one more question. That is by Rashi Sachdeva. Rashi, you can go ahead with the question quickly. Rashi, you're there?
Yes, sir. Yes, sir. Good morning, sir. This is
good
Rashi
morning.
Sachdeva.
Good morning.
Sir, can you tell something about aviation communication, like how to get into these industries?
Okay. Though I'm not an expert in this aviation industry, but I can give you some heads up. So aviation is a life critical systems, avionics and aviation systems, and they are hard real-time system wherein if you don't meet the deadlines, the result will be catastrophic. So a very different kind of a skill set is needed in those industry, I believe. Okay. And what was your question next to it? Your sub question?
How to get into these industries?
First of all, since it is a niche area, I feel if you have the right set of skills, um, you can pave your way to this industry. So one way I think is to get to know what it requires. Okay, for example, what kind of operating system is used in that area, master that. So master a few of the components, what kind of communication system is used in that area. So the operating system being used in aviation avionics industry, that has to have a different attribute as compared to the operating system which will run on your mobile phone. Okay. Likewise, the communication protocols that we will use in aviation avionics will need real-time characteristics and attributes which may not be there in your cellular phone. So that is a very niche area. Very less people will have those kind of a skill set. But if you have the right skill set and right competency, and you show, you come up on the global platform, project your skill set competency, I think you can make your way to aviation industry.
Okay, sir. Thank you so much, sir.
Thank you, Rashi. So we are running short on time on this session, and our second expert has also joined. So before I started the session, I was not able to introduce Mr. Shashank Vimal. So I'll just thank him at the end of the session. Hearty thanks from Oriental Group of Institute and the Department of Electronics and Communication, of which he was a part of as well. So it was great hearing from you and great to see you at such heights. Great to see you at such great heights. You have reached there. So just a hearty thanks from it. So good to see you over there. And even in the future as well, we look forward to having many more interactions from your end, guiding the students, guiding everybody on the ways in which you followed in your college days, so that you can, I mean, they end up achieving the same things as you have in your life. So thank you, Mr. Shank, for the
Thank you, Professor Ahmed, for your kind words.
wonderful information you have shared in this group and shared in this call.
Thank you so much for making me part of this. And this is an opportunity to connect back to my alma mater, my institute, wherein uh, uh, I studied. And this is a time when I can share back to the society. So I take this opportunity to share back to the society. And thank you so much for making me part of it. After such a long time, I could connect to you all, or to my institution to which I belong. It's such a pleasure. Thank you so much.
Thank you, Mr. Shashank. And we also have the privilege of now of the next speaker for the next session with us as well. So Dr. Karthik has also joined in. We welcome Dr. Karthik. Very good morning, and we welcome you on behalf of Oriental Group of Institutes to this third day of the Infocus 2020, which is a 4-day online symposium. It consisted of different kind of webinars and different kinds of activities. There were coding contests, and there were webinars, there were panel discussions. So we welcome you to this event. Before I start up with the session, I'd like to briefly introduce Dr. Karthik, who has a very rich profile, and I'd like to briefly introduce him, and then I'll hand over the host controls to sir. Uh, Dr. Karthik has done his MTech in Visual Information Processing and Embedded Systems from IIT Kharagpur, and he has done his PhD in Digital Image Processing from IIT Madras. Currently, he is working as a research scientist at TCS Innovation Labs in Bengaluru, Karnataka, and he has got lots of interesting interests in many fields like image processing and computer vision. So we look forward to a very interesting talk from Dr. Karthik, and I'll hand over the host controls to you, sir. Over to you, sir.
Hello?
Yeah, you're audible, sir.
Yeah, thank you. There was a disconnection in between.
Yeah, you're audible, sir. You can go ahead with sharing the screen, sir.
Yeah, thank you.
Just a second. It might. Yeah. You're able
Is
to
my
share the
screen
screen?
visible, Professor Ahmed?
No, it's not right now. Just a second. It might have. Yeah, you're the co-host.
No, I'm sharing my screen. I just want to confirm if my screen is visible.
As of now, it's not.
Okay.
Prabhat?
Yes, sir.
Yeah, is the screen visible now?
Yes, sir. Yes, sir. Yes.
No, is the screen shared from Dr. Karthik visible?
Yes, sir.
No, sir, it's not visible.
No. Prabhat, stop the share screen. Let Dr. Karthik share the screen. Dr. Karthik, if you can join back, and then again we'll pass over the host controls to you. Dr. Karthik got disconnected, so he's rejoining back. He has messaged me.
Is my screen visible, Professor Ahmed?
Yes, sir, it's visible now.
Okay, thank you.
Yes, sir. It's okay now.
Yeah, I'm extremely sorry for the delay.
Never mind, sir. Never mind.
Yeah, and thank you very much for your introduction, Professor Ahmed. And without wasting much time, let me start. And let me tell you this thing first, right? When many of the students listen to my profile, I just give it as a formality. Okay, it's not about scaring you out. And when people hear the profile saying that, okay, this person is from IIT Kharagpur and IIT Madras, currently is working as scientist, some big terms, IITs and everything, and then they'll come to a conclusion, okay, this guy is going to talk some hi-fi stuff. Okay, but if you have such kind of a misconception, I would request you to remove that from your mind first. Okay, and keep your minds open. Okay, see, a parachute can fly only when it is open, right? It can't fly when it is closed, right? In the same way, you will be able to absorb the things today only if you keep your minds open. Okay, don't have any kind of misconceptions about my profile, and just keep your minds open so that you'll be able to get the maximum out of this session today. Okay, I am going to keep the things as simple as possible. One of the biggest things that I learned from my father, he's a great teacher in chemistry. He teaches for +1 and +2. One of the biggest things that I learned from my father is to keep the things simple as possible. Okay, and so this is the outline of my talk. Initially, I'll talk about motivation. I'll briefly differentiate between computer vision and image processing. Of course, there's a very thin line. I'll talk about a basic block diagram. Whenever you're dealing with certain problems, whenever you're presented with certain image processing or computer vision task, how you should go about it, right? You need a structured approach in order to solve the problem. And applications in various engineering disciplines, and Python. I'll talk about briefly about how Python is being used for image processing and computer vision. And I'll talk about an application on optical character recognition as well. I'll show you some practical demo also online. And also, I'll talk about how image processing and computer vision has a great scope in addressing some of the important applications in order to fight against COVID-19. Right, so I'll talk about that. I'll also give you a pathway on TCS research and innovation. When the first session speaker, there were a lot of questions on the career guidance part, right? So I will not leave you just as floating. Like I'll not only talk about some great stuff that's happening in this area, as well as I'll also talk about some of the how do you reach or how do you get into the companies like TCS research and innovation, and then I'll conclude my talk. Okay, and without wasting much time, let me start and go ahead. And whenever you're trying to see a particular scene by using your human visual system, the vision sensors plays an extremely important role. If you see this diagram, it says 83% of your scene perception mainly depends upon your vision sensors. Yes, there are several other sensors which also have an equally important role. However, vision sensors plays a very important role. It's a 83%, which is more than, it's a majority of your scene perception, whatever you're trying to see or whatever your brain is trying to analyze. Okay, it depends on your vision sensors. Okay, what are the vision sensors in us? They are nothing but our human eyes, right? So this is a human visual system, and the human eyes are very important for understanding about a scene, right? So that is the exactly the same reason why today, if you see the industrial automation tasks, when a lot of people are automating their tasks in their industries, right? When they're automating the processes in their industries, right? So they are extremely making use of this either these video cameras or surveillance cameras. So some form of visual sensors are being used in order to for their automation, and that plays a very key role. Okay, and yet another reason why image processing and computer vision is extremely popular is uh, what is an image. Okay, internally, if you're trying to understand what exactly is an image, it's nothing but a collection of values or a matrix of values or a group of numbers arranged together in a specific fashion, and that itself will appear to you in as an image. Today, if you're seeing me on the screen, it's nothing but a set of intensities arranged in a specific pattern. Okay, is what is creating my image in the video screen. Or if you're seeing this slide, a group of intensities arranged in a specific pattern, again it's creating this slide the way it is appearing. Okay, so it's in the digital world. Yes, so this is how the images are being captured, right? So what happens in image processing and computer vision is, in majority of the cases, you will perform a similar operations across the complete image area. Okay, at each and every pixel position, you make use of this the computational resources like GPUs, which exist today from NVIDIA or from some other any other company. For that case, you many of your image processing tasks can be parallelized. Okay, and they can make extreme they can make an effective use of these computational resources like GPUs. Okay, and another important reason is these days every industry has a requirement for image processing and computer vision engineers, right? So because you take a civil engineering, mining, electronics, I'm going to show you some applications. Okay, gone are the days when people used to think that okay, image processing or computer vision is a subject restricted to EC or computer science. Gone are those days. Okay, every industry these days, no matter what kind of background you're from, there are opportunities in image processing and computer vision. Every industry is trying to adapt this technology of image processing and computer vision into their field, right? So you will understand over the next few slides, you will understand how people in different industries are they making use of this technology. Okay, so it's equally important that domain knowledge also plays a very important role. Suppose say a civil engineer is using this image processing and computer vision technology in order to automate the process of the crack identification in the bridges, the railway bridges. It's very, very important for regular inspection. And if a civil engineer wants to use this technology in order to automate the process of the bridge inspection, right? Then if he has to use it, then he needs the help of image processing or computer vision engineer. Suppose say an image processing and computer vision engineer is there in that particular site and he wants to automate the process of the crack inspection or the bridge inspection, then it's equally important that we as an image processing or a computer vision engineer needs to have a knowledge about the civil engineering domain, right? So else will not be able to automate the process, right? So domain knowledge of that particular field also plays an equally important role. Okay, and the cost of data acquisition is huge for certain applications. Let me tell you a scenario. When I was doing my PhD at IIT Madras, I was closely working with this institute called National Institute of Ocean Technology, and these people do see now that fossil fuels are getting extinct, and these people extremely make use of this robots, underwater robots. Okay, what they do is they'll travel to the mid areas of the Arabian Sea or Bay of Bengal, and where they think that there are probable resources of methane gas available there, right? So methane gas is known to be one of the alternatives of fossil fuels, and they'll get some kind of prediction. They reach to that particular site. Okay, for reaching that particular site, it will take them around 11 days. By the way, I'm not cooking this story. It's a real experience of a scientist whom I used to closely work with in National Institute of Ocean Technology there. Okay, 11 days they will travel there, and 11 days they'll come back, total 22 days. And obviously they'll stay in that particular site for 20 days approximately, and overall journey will be 45 days. And in this 45 days journey, if weather permits, during their stay of 20 days in that particular site, okay, weather permits, they will drop the robot for maybe 3 to 4 days approximately, not beyond that. Okay, that is how extremely critical these applications are, because they operate in hazardous environment, and the robots will cost crores of money. They have some valuable sensors equipped on it. Okay, they have to ensure that the weather permits first, and then only they'll drop the robot from the ship, and they'll operate the robot from the ship, and the robot does all kind of deep sea explorations, and it comes back and by capturing a lot of data. Okay, vision sensors is also one of the key sensors which is being used in such kind of a robots. Okay, and when these scientists are using that robots for such kind of a purpose, and whatever data they are capturing will be extremely valuable. Why? You may ask me why, right? So let me give you a scenario. You use your mobile phone. If you're capturing an image, okay, in your room wherever you are right now, and if the image doesn't come out well, what's the next thing that you're going to do? One of the next thing that you're going to do, you'll capture another image, right? The cost is not much over here. Okay, capturing another image. But suppose say they did all that explorations, and once the robot comes back, okay, and if they find that the images and the videos that they have captured have a lot of noise in it or the blur in it, or because of the lot of underwater currents. Okay, because of all those reasons, all these images or the videos that they're going to capture, okay, they'll have a lot of noise in it. Okay, and there, just because they have noise, again they cannot afford to go back and drop the robot again at the same location and capture the data, because it's an extra day. Again, the weather should permit and they should stay back for some more time. Okay, it's a huge cost that it involves. Whatever the data that they have captured, it's the responsibility of engineers like us who work in these technologies of image processing or computer vision, in order to improvise the quality of the data that they have captured, right? So per day cost will be 11 lakhs for the government of India for doing this kind of an explorations. You can imagine the cost of the total explorations, 45 into 11 lakhs. There's a total amount of money that the government of India invests in such kind of projects, right? So it's a huge cost. So in the same way, it's a same cost is involved for the satellite images also. There'll be few situations where you cannot again and again capture the data like the way you do with your mobile phone, right? But right, so in such kind of a cases, it's the responsibility of a computer vision and an image processing engineer to come forward and improvise the quality and help the marine scientists or the space scientists who are working with such kind of a data for their specific application. So this is a brief motivation and the importance of image processing and computer vision, right? So there's a very thin line between these two terms, where quite often these two terms are used for one for the other. But however, let me give you a brief what is the difference between these two terms. Suppose say you're giving image as an input, okay, and you're getting image as an output. In the deep sea explorations case, they have captured the data, they have come back, okay, and I want to build a system which can improvise the quality of the images, where the input to such kind of a system will be given as an image and the output is the better quality image. Now this kind of a task, the system this kind of a task, or the system which does this kind of a task, falls under this category of image processing. Okay, but when the image is an input and the description is an output, okay, when you're capturing an image and you're asking your system to identify what kind of an objects are there in that particular image, okay, then such kind of a task falls under computer vision. Okay, I'm going to touch about only these two things today on image processing and computer vision. However, computer graphics and artificial intelligence, I'm not going to touch much, but a part of artificial intelligence, deep learning, I'll also tell about briefly about how that is being used in some of the applications here. Okay, this is a basic block diagram. Given your a problem in image processing or computer vision area, how would you like to solve, or what is the structured approach of solving that problem? Okay, you will start with data capture. Suppose say you're using a drone in order to capture images or the videos, or you're using an underwater robot. Okay, you should ensure that the platform on which the camera is being mounted is working very effectively. Okay, you cannot allow to the best possible extent. Of course, there are few things that are not there in your control. Suppose say you're using the drones for the windmill inspection, okay, and there are your drone might be withstanding few some winds to certain extent, but it may not be able to withstand the heavy winds that might come in those regions, right? So it's very important that the platform on which the camera is being mounted is highly stable first. Okay, you have to ensure that at least whatever is there within your control. Okay, and then comes the pre-processing. Suppose say even after controlling a lot of things, there are few degradations that the images will have. Okay, then you should go with pre-processing. You should improvise the quality first before you pass this images with the further feature extraction, region of interest, and scene inference, right? So I'll talk about some of the applications in the later slides, and we'll map it to this basic block diagram. So you need not worry if you're not able to get much out of this particular basic block diagram. Okay, this is how it's being used in semiconductor industry. In semiconductor industry, if you see, there'll be a lot of silicon wafers, and now there can be sometimes in the manufacturing process there can be some defects on the silicon wafers now after the chip is being manufactured. Now now many of the semiconductor industries are using this image processing and computer vision in order to identify the defects on these chips, right? So there can be scratches, wafer peeling, partial dies, wafer contamination. So the majority of these defects, actually you can use image processing and computer vision in order to determine them, right? And there can be electron microscope images. And in fact, my wife is also a PhD from IIT Madras, Dr. Sankirtana, and she extremely works on these images called she extremely uses this scanning electron microscope and transmission electron microscope, where she images materials under with micrometer or the nanometer scale, right? So when you are capturing images with such kind of a fine resolution, what can happen is this even the slightest of the vibrations in that machine can cause or induce some kind of a noise in these images, right? So what now people are using this image processing and computer vision technology in order to remove the noise in these images first, so that it can be used for further processing. Maybe if my wife wants to measure what is the dimensions of this particular object in the nanometer scale, it's very important that first she should be able to get rid of all the noise which is there around, and then she'll be able to work towards improving it. In the same way, if you see, if somebody wants to get rid of the noise first, and then only they will be able to understand what is the object which is there over here. Okay, so the pre-processing step plays a very, very important role over here, right? So this is the pre-processing block. The data capture is through the electron microscope. Pre-processing has to be done before even giving it to feature extraction, region of interest, and scene inference. I'll talk about the other blocks as well. Okay, this is how it's used in industrial boilers. Suppose say you must have seen some videos in National Geographic or some online videos where the power plants, there are huge tons and tons of coal will be burnt in order to generate the power, right? So where the coal is being burnt and the fire is being generated, right? And now, of course, there'll be some kind of a mechanism which can convert this complete process into electricity, right? In this process, what can happen is sometimes the coal gets burnt inefficiently. Let me take this example. You must have seen, right? So the corn, corn will be fried on the coal, right? If you go to the streets on the outside, if it gets fried on the coal, and if the coal is not getting burnt efficiently, what can happen? The small pieces of the coal will fly away from that pan, and then it can come outside. That means that piece of coal is not burnt efficiently now. Okay, the same way, if this boiler settings are not optimum, what can happen is even the coal which is getting burnt here will not burn effectively. Okay, and it's a big loss for the people who are working in these kind of an industries, who are operating in these kind of an industries. Now what they are started using is they built something called furnace camera. It's a high temperature. Now it's very important the data capture should be properly done. Okay, because if the camera is not designed properly, what can happen is it can experience these huge temperatures which are there inside this industrial boilers, and then it can damage the camera. Okay, so the data capture process, the first step here should be very good. Okay, now what we need to do is, once what they are trying to do is, from the fire which is generated over here, they'll extract few properties out of this fire. After doing necessary pre-processing, they'll extract the fire features. Okay, and and then they'll identify the region of interest, which part of the fire they need to monitor in order to extract the properties of the fire. And then by using that as a clue, they'll start estimating what is how effectively the coal is being burnt efficiently. Okay, just take this as an what do you say, application at a higher level. If you're not able to understand the in-depth details, maybe you can get back to me at a later point of time. I'll be more than happy to discuss with you. Okay, but however, this is how image processing is used in order to determine the coal burning efficiency. Okay, the railway bridge inspection, right? So earlier, this is how they used to do is they used to carry the huge cranes, and the people used to regularly monitor the bridges, and then that's how they used to do it. This inspection has to be carried out very frequently, right? But however, nowadays, and this is a laborious process. If you see here on the right side, this person who is operating over here, using a drone and a camera is installed on it. And then what he can do is, instead of sending people like this, he can start using this drone and fly across these bridges in order to examine the every portion of this bridge. Okay, and if you're using this crane like this, what can happen is this can block the way of the train also, right? So but independent of that, what this person, civil engineer, can use is, he can use a drone and use the camera mounted on the top of the drone, do the regular inspection, and then do it. Right, this is how the technology of image processing and computer vision can be used very effectively. Okay, and the bridges are not there only on the top of the water, right? They are the some portion of the bridges are there below the water also. Now this is how they used to send the people, and then and then they used to have this regular inspection, right? That is how they used to do it earlier. Okay, but what's happening, this is, even if you see here, the person regularly visits these bridges and then do this regular maintenance work. But now what people have started using is, they have started using underwater robots, and they start sending they'll dip it, and remotely they'll operate and then examine these bridges, if there are any, if the part of the bridge which is there beneath the water surface, if everything is okay or not, or if it needs some kind of a specific attention, right? And now when you are operating in the air, the images that you capture have some form of distortions, but when you are operating inside the water, there will be some other kind of distortions. I'll talk about it. Okay, suppose say you want to detect the drainage pipelines inspection, and where the leakages happen, or if there is any blockage in the drainage pipes. It's very difficult for humans can go and do such kind of jobs, right? So what we can use this robotics technology integrated with vision sensors, and help these robots to navigate across these drainage sewage pipelines and do the necessary inspection in order to detect the cracks or any blockages that can happen, right? So this is how you can use this robotics integrated with computer vision or image processing technology in order to do this sewage pipeline inspection. But these are some of the challenges that can happen when you're operating inside the water, right? So if you see this picture, the light entering from one medium to the other medium, and because that the light ray is entering from one medium to other medium, what it can happen, the light ray changes the path in which it is traveling, right? So this is how this process is called as a refraction. Okay, because of this refraction, suppose say a fish is seeing the cat at this position. Okay, the cat which is there at this position, for the fish it will not appear at this position but at this position. This is called the virtual object position. This is called as a real object position. Okay, and this shift is because of the refraction phenomena that is being there. Okay, and these angles, the mathematical form which governs this law of refraction is called as Snell's law. And it's exactly the same reason here. If you see, during my research days or IIT Madras, what we did was we built an aquarium, and then in order to test our experiments at lab scale, right? So where we were doing, where a chessboard pattern was printed on a white paper, and then we laminated it and dipped into our aquarium, and we captured few images by using the camera which is placed outside. Okay, if you see that, what's happening over here, the vertical lines are getting bent, and the horizontal lines are also getting bent. Okay, that means the shape of the squares is getting distorted. These kind of distortions are called as geometric distortions. Okay, and one important point which I would like to drive here is, see, just because I'm working in underwater imaging, it doesn't mean that I should buy one waterproof camera and go across the oceans in the Marina Beach. Marina Beach is the one which is famous in Chennai, at IIT Madras, and I just go to do some water body and capture images. No, you should not do that first. Okay, if you're working in any area, you should start understand how do you build a prototype first at a lab scale. Okay, maybe in your lab by using few things which are there around you, and how do you do it in the similar way. Whatever algorithms that I have developed for improving the quality of underwater images, what we did was, I'm going to show you the my lab aquarium as well, right? So what we did was, we built a lab aquarium and we started doing some experiments inside it. Okay, and if you want to create some kind of an what do you say, the murky nature, right? So the water is not always clean, it's dirty, right? If we want to create such kind of a dirty nature, we started putting some kind of a dust, and which creates such kind of an, which can simulate the environment of real life water bodies. Okay, and then we started doing experiments in our institute swimming pool. Okay, at the next level, and then we started working with the data which are captured by the National Institute of Ocean Technology. It's a gradual process. You start building the prototypes, whatever. Suppose say you are building few algorithms, few real-time applications. Okay, it's very, very important. Not only about image processing, it can be any other field that you are interested in. You should start think about how do you build the lab scale prototype first. Okay, coming back to the challenges, this is another form of challenges. If you see the bottom row, the white light is decomposed of several different wavelengths in it. It ranges from 400 nanometers to 700 nanometers, and it captures several different wavelengths in it. And when the white light is passing through the water, what can happen is the red will be absorbed faster when compared to the blue or the green, right? It's exactly the same reason why the deep water areas appear in the bluish or the greenish tinge. Okay, let me take an example. Suppose say I have a red color water bottle over here in which the water is filled here, and what property of this water bottle is making it appear red? Because the white light which is coming out of my window is falling onto this red color water bottle and then reflecting back to my eyes or into this camera. Okay, and where the red wavelength of the white, the entire white light is being reflected back to the camera as well as to my eyes, and that property is helping me to identify this bottle as a red color. Okay, suppose say the red component of the white light itself is not reaching this bottle. Okay, and this bottle will not be able to reflect any other wavelength as such. Okay, and the red light will be all the other wavelengths will be absorbed by this bottle. That's the nature of this bottle. Then how will this bottle look like? This bottle will appear as a black now because it's absorbing all the wavelengths which is hitted onto it. Okay, that means the true color of this object is lost now. Okay, the same thing happens because when the white light is traveling through the water, the red component will be absorbed very very fast. And if I have a red color object over here, and since the red component itself is not reaching it, and there will be nothing to reflect back. Okay, and the true color of the object is lost, and this kind of a distortions where the appearance information is lost, we call it as an photometric distortions. Here they call it as a geometric distortions where the shape is getting distorted, and here the distortions where the appearance information is being lost, we call it as an photometric distortions. Okay, and this is one other very very interesting application nowadays. If you see Tesla or Google, they are coming up with a lot of what do you say, uh, on these driverless cars, right? They are using this technology called advanced driving assistance systems. In automotive industry, it's famously called as ADAS, ADAS, advanced driving assistance systems, where such kind of systems, how do they work is they have a lot of sensors. The car is being equipped with a lot of sensors, or the autonomous vehicle on which which is being used in this kind of a setup, right? So it's being equipped with a lot of sensors, and every sensor has its own limitation. Okay, it cannot it's not that it will, this kind of a car will operate in any kind of road. Suppose say you have designed an autonomous car, driverless cars in US, the same car can't be run in the Indian roads. Okay, because Indian road setting is completely different when compared to the US roads, right? So, and this kind of a systems today, actually they assume that the roads are clean, and the divider marks are properly visible, right? All the traffic signs are properly there. Okay, and it cannot afford to run. They'll not be able to operate properly when these kind of a the clear distinction of the road marks, everything is there. Okay, and for that sake, another place where it can't work properly is, suppose say you're driving using a driverless car on a hill station, it will not work properly, because in the hill stations you'll find a lot of haze in majority of the cases. And if there is a haze, the cloudy effect, okay, and the vision sensor, the camera will not be able to see for a long distance. Okay, it will not be able to see the long distance, and it may not help you in any way. Okay, and driving using a driverless cars in such a kind of an extreme environments, it will be very very harmful, right? So so whatever technology, suppose say want to build a driverless cars on riding on the hill stations, the ADAS system should have enough intelligence how to remove the haze or the foggy effect that you will see mainly on these hill stations. Okay, suppose this was one of the algorithms which I personally worked during my days at IIT Madras. So this was a dehazing effect. If you see, the visibility is very poor over here. This is a robot traveling inside the deep sea environment, and this is a video which I have taken from YouTube. And what I did was I have used my dehazing algorithm in order to improvise the quality. Here, if you see the rocks which were not visible properly here, they came into visibility here. The rocks which were not visible here, they came into visibility here. Okay, This is a dehazing. This is a lot of scope, right? So I don't say that my algorithm is super intelligent. Okay, it didn't work in all kind of scenarios, but there's a lot of scope for you to work on in case if you're interested to take up this kind of a problem, right? So and again, this is a kind of a pre-processing that is happening over here, right? So if before giving this kind of a data back to my marine engineer, it's very important, or before giving this kind of a data back to my back to the person who is operating this robot from the ship, okay, before giving that data, it's very important as a responsible image processing and computer vision engineer, I should help them to improve the quality of this data first, and then so that they can use it for further feature extraction, scene inference, whatever task they want to use it. Okay, but it's my role first to improvise the quality of these images, so that that will be helpful for those engineers, right? So another interesting application is the container yard surveillance. You must have seen the shipyards in many movies also, right? So in case if you are not from a coastal region, you must have seen these kind of shipyards in many movies, and there'll be a lot of containers which will be coming in, and there's a few containers will be going out. Okay, and it's very important that a person who is operating who's the owner of this kind of shipyard, it's very important for him to track which containers are coming in and which containers are going out. Okay, this is where this optical character recognition, the application which I'm going to show you a practical demo on how to use it, this is how it will be utilized. Okay, suppose say a container is coming in, this kind of a container is coming in, and the person who is operating, he wants to automate the process of this container ID recognition. Okay, what he can do, what's the best he can do is he can install a surveillance camera when the container is getting in, and from that surveillance camera data he can recognize the text and the IDs corresponding to this container yards. Okay, and then they can infer the whatever is the ID, and they can use some backend system, backend databases in order to update saying that okay, this container has come in, the container with this ID has come in, the container with this ID has gone out. Okay, that kind of information that can happen, because this is very important over here. Okay, and the another challenge here is sometimes the text will be written on the curvy surfaces like this. Okay, you must have seen these kind of a containers also. Okay, but my text processing software always assume that the text is very clean, it is free of distortions. Okay, but the text here will have a lot of distortions because it is written on the curvy surfaces. Okay, and now before giving it to my text processing software, in the pre-processing block, I should ensure that okay, this kind of an effect, or this kind of an effect is modeled properly, and the recognition with the text processing software happens correctly. Okay, so this is another challenge now in the container yard surveillance problem. Okay, and this is also a challenge, right? So suppose say somebody wants to read the IDs of the cable which are there inside the water near the lake regions, because you will see a lot of cables, current cables, or some form of cables will be running around, right? So and okay, some form of cables will be running around, and if you and the water is very clear, right? So
I think Dr. Karthik has got disconnected. He'll join back. Vivat, can you hear me?
Yes, sir, I'm here.
He's back.
Okay.
Professor Ahmed, am I audible?
Yes, sir.
Yes, you are, sir. Yes, you are.
Okay. What's the last slide that you have seen?
I think that was a video on that.
Okay, sure. Okay, not a problem. Are you able to see my slides?
Yes, we are.
Okay, sure. Thanks. And so now you have a lot of electromagnetic spectrum. There are a lot of other wavelengths. Okay, not everything you can see just by having an visual sensors as such, right? So there's something like infrared. There's something like maybe the X-rays, right? So I'm going to show some application on X-rays as well, right? So if you want to measure temperatures, that can be done in the near infrared region. And in the satellites you will find this kind of a data which is there as a multispectral images, right? So there are a lot of other wavelengths as well. And again, it's the same images. However, the images in every domain has its own meaning. Suppose, say, the color coding of this image, of this thermal image, indicates the temperature. Okay, and the same thing, whatever image that is being displayed over here, the X-ray image indicates something else, right? So you have to understand the domain also now, what kind of image modality that you are using, whether you're using infrared, microwave, visible, ultraviolet, X-ray, which wavelength range that you are using at your end, right? Okay. So this is another industry where I was closely working in the mining industry, right? So let's try to understand how the image processing technology will help these people, right? So these mining industry, what happens is the video which is shown over here, this mining region, they operate on a geothermal vents. Okay, when I mean by geothermal vents, you have lot of it's a heavy temperature, the temperature intensive regions. Okay, if you see here, if you are digging at an inappropriate location, there'll be a lot of heavy steam outbursts that can happen. Okay, and if you see here in this is also a steam here, this is also a steam here, but this steam is very dangerous. Okay, now the ask, one of the important goal that was assigned to us was, can we use this surveillance data which is available to us and detect these kind of an steam outburst regions well in advance, and alert the people who are working in those regions appropriately so that their lives can be saved, right? So the mistakes happen, right? The steam outbursts can happen because these are under the geothermal vent. Sometimes you will not be able to predict exactly the location at which you want to dig. Okay, so these things will happen, and then uh, and heavy steam bursts, outbursts can happen. Now it's a responsibility of me in order to help these mining engineers to work efficiently, and if there is any disaster that's going to happen, I should inform them well in advance so that they can get back. Okay, for which what we need to do, first we need to identify the steam regions, and among these three steam regions, I should help them understand that the steam region which they are operating currently is very disastrous. I should also tell them the other steam regions which are there so that they are not going near to that location and they are moving far away from that place until the steam outburst settles down, right? So this is the kind of application in the mining industry that you can see, right? Digitizing heritage sites. The many times you might be seeing in movies, right? What can happen is this cultural heritage sites in Indonesia also. I've heard a lot because of the tsunami. There were few temples which got buried in the deep sea regions. Okay, and if normal people like us, if they would like to go ahead and try to understand more about those temples and try to understand more about the culture that was existing in the past. Okay, am I audible?
Yes, you are, sir. You're audible.
Okay. Yeah, sure. Sometimes what can happen is, if you want to understand what people have started, what government of India have started initiating is, they have sent people, the scuba divers, they have captured a lot of images of those kind of a sites. Okay, they're creating a virtual 3D map out of it. Okay, and in such cases, okay, if you have any kind of an, what do you say, any kind of a broken statues like this, Okay. In the 3D digital world, what you can do is there are few advanced techniques like 3D in painting. Okay. By using that technology, you can fill in this missing portion and then recreate this statue like this in the digital world. Okay. So that you have a smooth experience when you are using this 3D, when you are navigating this temple in the 3D virtual world. Okay. So this is what I mean by digitizing heritage sites, right? So this is a kind of application, again, is computer vision, and the geometry based computer vision in order to restore these structures plays a very, very important role, the 3D processing. Okay. One other thing that we did is we restored this thing. Okay. Initially we had this model, right? We had this 3D model, and we gave this 3D model to the 3D printing technology, the 3D printer which was there in our campus. Okay. We printed this 3D model. Okay. And again, after restoring it back, we again printed this 3D model, in the form of a small object. Okay. So that we'll be able to clearly see that the broken part was missing in the first 3D model that we have printed, and in the second 3D model, it got perfectly restored back. Okay. It's not only about seeing in the simulation software, in reality also we started seeing it, right? So this is the advantage with digitizing these heritage sites. This is how it's being. There's some more applications like forest inventory counting. Suppose, say, a paper manufacturing firm who was closely working with us in our company, they want to track the number of trees which are there in the forest. Okay. And we built a drone based solution for them, where the drone was flying on the top, and then we created the 3D map of the trees from the top. Okay. And then we started counting the number of trees and identifying the number of trees with each and every tree, how many number of trees are there with a specific category. All these things we started doing as per the client requirement. Okay. And the warehouse monitoring is another thing. You must have seen the Amazon warehouses or the Flipkart warehouses, right? There'll be huge warehouses, right? So in order to keep the stock maintenance, what they typically do is they'll go to every carton box and they use this laser scanner and then read the barcode individually. Okay. But however, it's a human intensive process. So we gave a drone based solution to them, where the drone will fly across the complete warehouse and they capture the barcode. Because nowadays, if you see, this Paytm transactions or the phone pay, all these mobile based financial transactions, they happen through scanning the QR code. QR code is one form of a barcode itself for you, right? So you will read the data and then you will have a note in your database back, right? So that is how the forest inventory counting that can happen, right? So now the warehouse monitoring that can happen, and by using drones you can automate it. Okay. And the high voltage transmission lines inspection is another interesting technology, because earlier they used to use the helicopters that fly across the regions, and then they started monitoring the transmission lines properly. But now we can send the drones again. Okay. Another challenge is should not have an interference with the high voltage transmission lines, because the drone is a moving object. Okay. Should carefully design the drone in such kind of scenarios. The windmill inspection, right? So even if there are cracks earlier in the windmills, it's very important for us to do a regular maintenance, so that the windmill will operate with a maximum efficiency. Okay. Again, we offered a solution by using drones and carrying a camera on top of a drone, and we built a custom drone for this client. So the document digitization, I'll talk about that document digitization. Okay. So let's see, all these hi-fi applications is fine. Okay. But as a second year, third year, or a fourth year student, no matter what kind of a background that you're coming from, okay, if you ask me what is a starting point for you to learn this subject of image processing and computer vision, then I think from this slide onwards, I'm going to show you what is the path for you to learn this particular subject. Okay. Anything that you learn over here that gets inspired from your human visual system. Suppose, say, you want to build a system automatically detecting some objects in my room. Okay. Then you should first start understanding, as a human, how will you do it? Okay. It should be a bio inspired thing, human inspired thing, right? So once you have that understanding first clearly, then you can build your system very, very efficiently. Okay. For which you need to understand what are the different components of your human visual system. Okay. In human visual system, one of the key components, the sensors which are there, are the rods and cones. The rods are used to detect the intensities, whereas the cones are used to detect the color information. Okay, and if you see, the cones are there in red, green, and blue, and these are the three different wavelengths that are being detected, and the rest colors in the visual spectrum are generated as a combination of this are red, green, and blue. Okay, and this is a basic image formation, right? So you have an illumination source. Suppose you are seeing me as a person, how you are able to see me? The light from my window is falling on me and falling onto my laptop's camera, and then you are able to see me. That's how you're able to see me. Okay, if the light is not falling, you'll not be able to see me, right? The same way, this is how we as a humans we capture the information. And if you want to design a camera system which can help you to capture few images, okay, then this is how the camera imaging system will look like. The illumination source falls onto an object, the light gets reflected and reaches this imaging system, and based on the amount of light that reaches this imaging system at different positions, okay, these are the set of sensors will be there, and based on the amount of light coming at a specific location, the sensor at that location will record some form of an something called an intensity. Okay, I'll show you in the further slides as well, right? So this is an analog signal that is coming into your image system. Okay, and you have to discretize it first in order to storing it. You cannot store an analog signal as it is. You have to first digitize it and then store it. Okay, and these are the main different components of your image processing system. Okay, if you are building some form of an hardware which can do some of your image processing tasks, this is a basic components that you will have. You have image sensors where the light is coming from, okay, which captures, and you have a specialized image processing software which does all this conversion of image. What do you say? Your analog signal conversion into digital signal. All that specialized image processing hardware will be there, right? And this camera system will be connected to the computer. Okay, and so that if you want a hard copy of it, you can print it. Okay, or if you want to improvise the quality of the images that your imaging system has captured, you can use some form of an image processing software. Okay, and you want to store all the images first, whatever this hardware has captured, you want to store it, you can do it on a mass storage on the hard disk or something. Okay, you want to see those images, you have a displays, and you want to transfer these images to a different location. Suppose you want to send me an image, because and then your computer should get connected to the network, right? So these are the basic components of your image processing system. And if you see over here, these are the fundamental steps. Okay, and you have an image acquisition, right, where the image is being acquired by using your camera. Okay, sorry for the bad quality of this image. Okay, but and if you see here, this is the another step where you will start filtering this image or enhancing the improving the quality. And even in image restoration also, you will improve the quality of the image. Okay, and if you have a color image, because there are two kinds of images, you have color image as well as a grayscale image. I'll show you what is the difference between them. Okay, but if you have a color image, you need a different set of processing that needs to happen on those kind of an images. Okay, and if you want to improve the resolution of images, you can use something like wavelets or multi-resolution processing. Okay, and you cannot store the image as it is. You have to compress the image by using something like JPEG compression or MP4 in order to store the videos. You have to compress them first, and then you can store them. Okay, morphological, something related to shape, and these are something like segmentation, representation, and description, and the object recognition. If you see, if you take the example of that forest inventory counting, where I have to detect the trees, first I have to segment where in my image the trees are there. Okay, and I have to segment the individual trees, because there will be multiple trees in my image or the video that I capture. Okay, first I have to segment them individual trees, and then once I have identified the individual trees, I should be able to determine which tree is belonging to which species. Okay, so I should be able to do all those things, for which representation and description, object recognition is going to help. Okay, so if you see here, the output of all these tasks actually are nothing but the images only. Okay, but the outputs of this process is generally image attributes. Okay, so all these tasks actually come under this process of come under the category of image processing, while these tasks actually come under the category of computer vision. Okay, and this is what is a grayscale image. Typically people call it as a black and white. Okay, And if you see in the grayscale image, the intensity's values will vary from 0 to 255. Okay, as I said, image is nothing but the internally it is represented as a matrix of values. Okay, and the value at a specific location in this matrix is determined by the amount of light intensity that is coming in from the scene element. Okay, suppose it is 112, suppose and here it is 106. That means the light rays which are coming in here at a specific location is direct is determining this. The sensor capturing these light rays here is capturing 112, and the adjacent location sensor is capturing is capturing the information, and it is reporting saying that okay, it is of 106. That means lesser number of photons or the light energy has reached that particular location. Okay, in a very layman terms. Okay, now you have color images also. Now the way and how these color images are represented, go back to the human visual system. If you see, I have three different wavelengths, red, green and blue. In the same way, my color image is represented as three different matrices: red matrix, blue matrix and the green matrix. Okay, these are the three different matrices, as a combination of which the several different other colors will be displayed over here. Okay, and these are the several useful Python packages which can be used for image processing. For somebody who wants to get started with the use Python programming for image processing, these are the basic image processing libraries that you can make use of, which are available in Python. One of the main misconception here is okay, MATLAB is what mainly people will hear about. Okay, but MATLAB is not very much acceptable in industries, at least for an image processing scenario, because MATLAB processing is very, very huge. Okay, and but one of the advantage of MATLAB is it's quite easy to learn. But however, it's, if you know MATLAB and the C language, if you had in your first year, then it's equally easy for you to learn this image processing, Python using image processing also. Okay, Python is not a very difficult language. Okay, and one of the major conception I used to have is, I am also from electronics and communications background. I used to feel that okay, as an ECE engineer, I don't need programming knowledge at all. Okay, that is a major misconception I used to have. Okay, but if you have such kind of misconceptions, please remove it. If you don't know programming, you will not be taken in the industries these days. Okay, programming knowledge is very, very must. Okay, you need not be an expert programmer, okay, who will be able to solve the challenges and everything, but at least you should know the basics, so that when the certain problem is given, you should be able to code it immediately, and then you should be able to report it back to your manager, right? So at least a basic Python programming you need to have. Okay, if you have such kind of misconception, then you need not fear. And I always used to think that okay, programming is not something like my cup of tea. Okay, or whatever it is. Okay, and afterwards I faced a lot of difficulties in order to pick it up. Okay, but now I'm fairly comfortable with Python programming these days, because that is what is used in our company TCS Research and Innovation majorly. Okay, even C programming few people use, but however, my team to which I belong, machine vision team, we use this Python extensively. Okay, and let me at this stage, I'll use my browser. I'll show you some practical stuff. Is my browser visible? Can somebody confirm?
Yes, sir. It's visible.
Okay, thank you. Okay, this is the Colab environment. Okay, Colab is offered by Google. Okay, how will you go there? What you need to do is, you need to type as Colab in Google. Okay, and this is a majorly based out of, you can do Python programming here, and any of the image processing tasks you can actually do it here. Okay, once you open the Google Colab notebook, okay, what will happen here is, okay, this, you will see something like this. Okay, and it's very important that you need to ensure that this is connecting, and what it offers is the NVIDIA GPU to you. Okay, these days there are a lot of organizations like Kaggle or Google. These people offer the free GPUs, and if you want to do some extreme image processing tasks, or you want to start learning some machine learning, deep learning, AI, Python programming related to these subjects, then what you can do is you can comfortably use Colab. Okay, I'm just reconnecting it. Okay, and if you see here, it starts allocating some form of a resources to me. Okay, and once it is connected, what you need to do is you need to mount your Google Drive into this Colab environment, because this Colab, whatever data that you are reading into this Colab, or the images that you are reading into this Colab, actually you should mount your Google Drive first, and then do it. Okay, if you see here, it will ask me to do this. Okay, and then it will ask me to point out the exact Google Drive, because multiple email IDs are registered on this system as of now. Okay, I'm giving it which Google Drive I have to use it for accessing the data. Okay, once I've given it, it will ask me for a success code. Okay, it will ask me for this success code. Just a second. Okay, and then and this authorization code, I'll just give it here. And by giving this authorization code, what happens is my Google Drive will get mounted over here. Okay, if you see here, if it's not appearing, I just press refresh, and the Google Drive is accessible to me within this Colab environment right now. Okay, and once I have this Google Drive, I'll use this folder in order to access these images. Okay, and for checking what kind of an NVIDIA resource is available to you in this particular Colab session, one of the limitation of Colab session is it's available only for certain duration of time. Okay, and this is the GPU that is being associated with it, 16 GB GPU RAM. Okay, if you want to buy from outside this particular GPU, I think you have to spend at least few lakhs in order to do it. Okay, you want to have it, but at least as at a student level, if you want to build some projects in this Colab environment, you can very well use you want to build projects, then you can very well use this Colab environment. And I'm entering into this drive, right? So I want to get into this drive in order to access my images. I'm using the CD command for it. Okay, and I am going into this select smart demo folder, and now I am into this select smart demo folder now. Okay, I can start accessing my images. Okay, I'm using importing these libraries. If you are comfortable with C language, you must be very well aware that you will use this statement called hash include stdio.h initially. So for which and the analogous way, what you need to do is you should start importing the OpenCV libraries. OpenCV libraries are the ones which are used for importing the computer vision libraries. Okay, and or the image processing functions. Majority of the image processing functions with there in OpenCV. I am importing another image processing library called Matplotlib. Okay, this Matplotlib is used for displaying. Okay, displaying these images. I can also use the displaying these images by using OpenCV library, but there's a challenge with Jupyter Notebook in this Colab environment, that this particular IM show function within this OpenCV libraries is disabled in this Jupyter. Okay, the Jupyter Notebook, you call this environment as an Colab environment, and this is a Jupyter Notebook that you're operating from. Okay, and once I read this image, in order to display, I'm using this. That's the reason I'm using this pyplot. Okay, and this img, if you read, you'll start reading this image. Okay, and print this image. Okay, once you have printed this image, what is displaying is a matrix of values. Okay, once you have displayed this matrix of values, as I said, right, what is an image? It's nothing but the collection of values arranged in the form of a specific structure. Okay, and I am displaying the image over here in the grayscale. Right, and this is the color image I have started reading, right? So I am using the same IMRead function in order to read the color image and displaying it. I am displaying the shape over here. If you see 288, 288.3, if you see, it has 3 channels along with the 3 different matrices. Okay, indicating red, green, and blue components. Okay, but the way they are arranged, what is the first component, second component, and third component, you need to understand that also. Okay, when you are reading an image through OpenCV libraries, what will happen is the first component, the 0th index will indicate the red component, the first index will indicate the green component, the third index, sorry, the first index will be indicating the blue, the second index will be indicating the green, the third index will be indicating the red color. Okay, but the matplotlib assumes that the first index is the zeroth index is the red color, and the second index is the green color, and the third index is the blue color. Okay, this is the order with which the matplotlib expects. If I'm not changing that order after I read through OpenCV library, it will display a wrong image. This color is not exactly correct. Okay, what I started doing is I'm using this color transformations of converting this BGR format to RGB format, and I'm displaying it again. Okay, the shape has not changed, but the true colors are retained. Okay, and now before going further, if you see here, I want to use some form of an text processing software. Okay, so I want to I'm going to show you an image. How do I read the text from the images? Okay, what is text? Suppose say I've shown you that container yard surveillance, right? Where you start reading the IDs of the container from the images and the videos that you capture. Okay, that technology we call it as an optical character recognition technology. Okay, because your image is nothing but the collection of values from this matrix of intensities. Suppose say even if you read the text image, this is how your text image will look like. Just by using this matrix of values, how do you infer what is the text present in this matrix of values? Okay, inside this, embedded within this matrix of value, you need to use the text processing software, for which you need to install these two packages, Tesseract OCR and PyTesseract. Okay, what you need to do is you have to click this. When you click this, it will execute this. I've already installed it for the saving some time over here, and I will read some text image over here. If you see text underscore image, which is there in my Google Drive, I'm reading it by using the OpenCV libraries. Okay, and what I'm using is I'm using a boxplot function over here, where inside my boxplot function, what it does is it uses the PyTesseract library and extract the text information first into this dictionary called D. If you are comfortable with Python programming, there's a structure called data structure called dictionary. Okay, it stores the values in terms of an what do you say, the key value pairs. Okay, it has this dictionary D has all the information about each of these text words, and where all in which locations these text words are there. Okay, since I know the locations of these words, okay, what I will do is I will use this the cv2 dot rectangle function. Okay, for which I'll pass my image input, the text image input, as well as the location and the first location of the word which I found out. Okay, and always also I'll send the how much width it is, how much height this word is spreading across. Okay, once I give this information, this particular cv2 dot rectangle actually draws this bounding box around this individual words. Okay, and this pytesseract dot image to string, it captures all the text information which is present there. Yes, of course, it's not doing exactly correct, but however, it is capturing all the words, majority of the words as such. Okay, but now what I want to do is when you are reading the text documents by using your scanner, sometimes there will be huge noise in it. Okay, and I'm trying to simulate that noise now. What I'm trying to do is I'm using some function called salt and pepper noise, where I'll add the noise over here. Okay, I'll add the noise and then display it. Okay, and now when I use a box plot on top of this noisy image, what it can happen is it will not be able to perform well. Okay, so what I'm trying to do is I am removing the noise. So I'm using this remove noise function in order to remove the noise, and then it will again, my text processing software will be able to identify the words properly and the text also properly. Similar to the way the noise is, sometimes the documents will have some form of a watermarks. If you see, this is the draft word is written as a watermark. Okay, if I give this kind of an image to my text processing software as it is, it will produce a lot of errors. If you see, this is the text which is informed, which doesn't have any meaning at all. Okay, but if I write a function for removing the watermarks, okay, and then write a small function for it, right, the watermark is removed and the text is inferred very well over here. Okay, so what does it mean now over here? Okay, so before carrying out before doing any kind of an application related to image processing, the pre-processing plays a very important role, because this text processing software called PyTesseract assumes the input image to be given with a clean image where the noise is not there, all these watermarks, all sorts of distortions are removed. I'll use my PPT again back. Is my PPT visible now?
So we are still in that collab environment.
Oh, okay. Just a second. I'm sharing it again.
Yes, yes, sir.
It's visible, right? Okay.
Right.
Right. These are the other distortions that you can see. Actually, there can be blackheads, right? So blackheads, low resolution, perspective distortion, skewed text, watermarks. So several other distortions. Before even giving these images to the text processing software, you should be able to remove them, right? So these are steps of OCR. I'm skipping it due to lack of time right now. PyTesseract and OCR, Tesseract OCR should be installed on the Colab. The rest of the packages like OpenCV and everything will be automatically installed. Okay. And for COVID-19, if you want to use image processing and computer vision, there are several different applications. Due to restrictions from my company, I'm not putting the images as such, but however, I'll give you a brief overview. Suppose say you want to ensure that social distance is being maintained in the public places. What you can typically do is, from the surveillance data that is captured, you can identify where the people are there, and then you can ensure whether two people are standing with enough distance in between as per the recommendations laid out by Government of India, right? So whether they are following the rules and regulations or not. Okay, this is how you can ensure that. And another thing is for companies, right? So when people are entering into colleges or companies, what you can do is you can use some form of a surveillance camera or some form of a camera which captures the faces and ensures that, okay, this person is wearing mask, this person is not wearing mask, and also use some form of a thermal camera on top of it and ensure that the temperature of that particular person is correct. Okay, and if everything is fine, then only you allow the person in, else you will block the access for him on that particular